Yes. So you're saying that all the terms have to be the same, or just certain ones have to be the same?
Well, in order to get a contradiction, it's enough to notice that those. Well, imagine a function e, right? I give you a function. I write down a function, and then you do something to this function. Differentiate twice with respect to x and y. And then you do something else, differentiate with respect to x, y and x in different order. Well, what do you expect about those two results?
Is that the same order?
Well, they must be exactly the same. Just exactly the same, right? Because those are derivatives of the same function. And we know it doesn't matter how you order the partial derivatives. So, if the function e exists, these must be exactly the same. Well, of course, up to change of the order of summons, and I don't know if you write 6 as 12 divided by 2, well, it's the same thing, right?
Could you have like different ratios? Let's say like for your e x y you had 2y minus x minus 3z, and for EYX, you had 4y minus 2x minus 6z. Does that work? Does it work out like that?
No. Well, these two are not the same. Right? This is twice greater than this one. And I'm saying that these must be exactly the same. Well, there's some simplicity that I'm bringing here by giving you the functions as polynomials. The simplicity is that you can easily simplify polynomial expressions, and you can easily check whether these two expressions are the same or not. Right? If I were to use some trigonometric functions, then it's not always clear that sine squared plus cosine squared is actually equal to 1. You may have some strange expressions trigonometrically that are actually equal to a number, but it's just hard to notice. But for polynomials, if you simplify each of those, and those are supposed to be simple, so for polynomials, they're either the same or not. You just see it.
So is there like some advantage to doing the whole like first step that you did instead of just taking the partial derivative of xy and yx and seeing if they match up?
Well, if I knew where the problem is, right?
Oh, I see.
If I knew, then yes. Then this step is not needed at all, right? So if someone told you in the beginning, well, if you look at this system, these two equations contradict each other. Well, then, yes, then you know how to go about it. But this step was needed to figure out where to search for a contradiction. Because it could be that the first equation will match the third one perfectly, right? And then there will be no contradiction by differentiating first and third and comparing. Right? So you need this step to figure out which two equations to compare. And then you forget about it and do the comparison and say, oh, this is the contradiction. Yes?
So is the x squared y term also a contradiction?
X squared y, yes, it is also a contradiction.
So we have, if we didn't look at that one first, we just do the same to it.
Well, basically this mismatch will suggest doing exactly the same thing.
What about all those other terms that don't match?
Well, you see, they don't match differently.
Oh.
Right? So what we see here is that this term is completely about y. So that can be a part of that constant.
Okay.
Right? And this is about y and z, so this term can be there.
So the ones involving x.
And this can be there. But the one involving x cannot be hidden in this unknown function. Right? So, you see, the thing is that we basically know nothing about this constant. That can be anything in terms of y and z. So anything that you can hide there can be hidden there, possibly. But this cannot be and that cannot be. Well, there's also probably a mismatch with something we have here that cannot be hidden into constant of x and z. Right? This term, xy squared, is not in terms of x and z, and it's not matching anything else in this expression. So this is also a problematic term. It doesn't match the term 0 from the second equation. Right, so basically when we do this differentiation, derivative of that with respect to x and y results in 2y in this term, and derivative of this with respect to x and y results in 0. And this 2y doesn't match 0, so that's also a contradiction. This imaginary 0 that doesn't match 2y, and minus x doesn't match 6x. So there are basically 3 different contradictions hidden in this equation. I'm not sure if there is a mismatch of one of these equations with the third one, but I don't have to check it because once I have one contradiction, it's enough. Okay. So this is the piece of work I will want to see on the test in case your answer is none. So although you get your point for almost free, you still have to do some essential computation to prove it. Because without it, I mean, anybody can type none in no time without any understanding. Yes.
So the contradiction in the first part is enough to prove that they're not.
Well, the contradiction is that these two expressions are not the same.
But what about the contradiction above?
Contradiction here?
Yeah.
Well, I wouldn't want you to go into explanation that, well, this term cannot be hidden inside that function.
Would that be enough? Without going to the partial differential?
Well, I would like, for some reasons, I would like you to go into precise explanation.
Okay.
Because basically, well, if you think about what explanation is, what does it mean to explain something? To explain something, you reduce a complicated stuff to simple stuff, right? Isn't that what explanation is? If you want to explain something, it means that something is complicated, and you use words, you use pictures, you use whatever means you have to bring it to the level of simplicity. Right? So this is what I would like to see in your work here. I believe that explanation at the level of this term cannot be hidden into an abstract function of two variables y and z is sort of complicated to be a contradiction. So what I want you to do is I want you to figure out how to do some steps and to show a different contradiction, which is much simpler. A contradiction in a way that this formula is not the same as that formula. So I totally agree that this explanation is a contradiction, if people understand it. Right? So what I want you to learn how to do is to explain things even better, to make them even easier.